This video focuses on logarithmic functions and will answer the essential question, how can you use properties to simplify logarithmic expressions? The first property we're going to look at is called the product rule. And the product rule says if you have the logarithm base b of a product, let's say xy, then instead of one logarithm of a product, we can actually rewrite that equivalently as the log base b of x plus the log base b of y. So one logarithm of a product gets split into two separate individual logarithms of each factor of the product separated with addition. So the examples below we'll see the log base 3 of 15. Applying this product rule to the 15, we can rewrite this as log base 3 of 3 plus log base 3 of 5, since the 3 and the 5 multiply to get our original 15. Well, this actually is helpful because log base 3 of 3 simplifies to 1 plus log base 3 of 5, and without a calculator we won't evaluate log base 3 of 5. With a variable expression here in the second example, number 2, log base 7 of 7x can be rewritten as log base 7 of 7 plus log base 7 of x. Again, by applying the product rule, log base 7 of 7, this simplifies to 1 plus log base 7 of x. So it's a way of taking one logarithm that's a product here and splitting into the sum of two individual logarithms. The reverse direction is also true. We can also go from two logarithms with this common base being added together to combine them to be one logarithm of the product. The second rule is called the quotient rule, and this is going to be very similar to the product rule, only in this case we're going to take the log base b of a quotient, we'll say x over y, and that one logarithm can be rewritten as two logarithms, log base b of x, the numerator, minus log base b of y. So it's a way of taking a quotient that we're taking the logarithm of, splitting the quotient into its numerator and denominator as individual logarithms, and subtracting the log of the numerator from the log of the numerator minus the log of the denominator. Excuse me. The examples down below, we can rewrite this first example as the log base 3 of 2, since 2 is the numerator, minus log base 3 of 9, since 9 is the denominator. Applying some of our understanding of what logarithms are, the log base 3 of 9 is equal to 2, and so we can actually simplify that second logarithm. The second example, log base 7 of x minus log base 7 of 49. Using the quotient rule, we can split up log base 7 of x divided by 49, this quotient here, as two individual logarithms, and subtract them. And again, for the same reason as example number 1, since 49 is 7 squared, log base 7 of 49 is equal to 2, and we can simplify that. The third rule is called the power rule. We've actually seen this before. If we have the log base b of x raised to the y power, so that's the x being raised to the y power, then this can be rewritten so that that exponent y actually comes to the front as a coefficient, y times the log base b of x. We've seen this in the basic properties of logarithms where the b and the x are the exact same number. But now this is a rule that applies even if the b and the x are different numbers. This rule still applies. So for instance, this first example down below, we're raising 9 to the 4th power in our logarithm. So we can actually move the 4 as the exponent out to the front as a coefficient, and now we have 4 times log base 3 of 9. So the 4 is no longer the exponent, it's in the front, and we just are left with log base 3 of 9. We saw this in the last example. Log base 3 of 9 is 2, so this actually is 4 times 2, which is equal to 8 as our final answer. In the second example, we are raising x to the 2nd power inside of our logarithm, so the exponent 2 can come to the front as a coefficient, 2 times, and we're left with log base 7 of x. The last rule is the change of base rule, and this might be the most useful to us, and that tells us that we can take the log base b of x, and if we don't want the logarithm to have a base b, we can make it any base we want to by choosing some alternative base. We'll say log base c of x in the numerator, and we're going to take log base c of the old base b in the denominator. So the old base b actually is now the thing we're taking the logarithm of in the denominator. Some useful new bases are base 10 and base e. Those give us our common log and our natural log. So a lot of times we'll take a log base b of x and rewrite it using only common logarithms. So common log x divided by common log b. That'll change whatever the base b used to be into now a logarithm with base 10, or we can also choose the natural log, which has a base of e, natural log of x divided by the natural log of b. The thing about this rule is that it tells us it doesn't matter what base we choose for our logarithm, the ratio of the log of x divided by the log of b will be true no matter what base log we choose. It could be some constant c, it could be the common log, could be the natural log. The examples down below, log base 3 of 5, this can be rewritten. Let's start with the common log. We'll do the log of 5 divided by the log of 3. Notice the base 3, that's the logarithm in the denominator of our change of base formula. So log of 5 divided by the log of 3. Now I'm actually going to put that in the calculator and see what the log of 5 divided by the log of 3 is. And I get roughly 1.465. And to check that it doesn't matter what base we choose, I'm also going to try the natural log of 5 divided by the natural log of 3, and see if I get the same answer. And after plugging that in the calculator, I can verify these are in fact the same answers. It didn't matter if I chose a base of 10, it didn't matter if I chose a base of e, I got the same answer. And typically we apply the change of base to take a logarithm like number 2, log base 7 of 6, and to rewrite it into a form where we have a calculator function, the common log calculator function, log 6 over log 7, and this is an expression we can plug into the calculator to get a value for, whereas the log base 7 of 6, the way it was originally written, we don't have a log base 7 button in the calculator. So log base 7 of 6, we apply the change of base, we get log 6 divided by log 7, plug that into the calculator, and get an answer of about 0.921.